Hello, everyone. Welcome to today's webinar presentation, Biogas Best Practices, which will discuss safety, cleaning options, and equipment maintenance. My name is TJ Willits, and I'll be your moderator for today's technical webinar. Just some notes to go through before we get to the technical portion of the webinar. You obviously should be hearing me speak now. There are two ways to listen to today's presentation. That's either through your headphones or computer speakers. Or if you have issues with that, you could also rely on a phone call or a teleconference. You could switch to that mode and it'll give you a number to go ahead and dial in, and you could listen to the presentation over your phone. Everyone's microphones are going to be automatically muted in today's presentation, and also the webinar is being recorded and it'll be sent out a day or two after the webinar. Though everyone's microphones are muted, we want to make this presentation as interactive as possible. So if you look on the right-hand side of your screen, you should see a question panel. If you have a question at any time throughout today's presentations while the panelists are speaking, go ahead and enter it in there and we'll get them queued up and answer as many questions as possible at the end of today's main portion of the presentation. I just want to remind everyone, if you're new to these webinars, we really have a great opportunity to get caught up in some of the topics that we discussed in the past. If you head over to our website, veoliawatertech.com, you can head to our on-demand webinar library, and our anaerobic operators webinar series are all cataloged there. And this one will be joined to the archive as well after the presentation. So you can watch those webinars at your leisure. Now, if you're here for the live presentation, you will be provided a PDF participation certificate, and those webinars will be sent out a day or two after the webinar. Also, we know that some of the people online might be watching with a group, or there might be multiple people within an office. If that's the case, if you need additional certificates, participation certificates, in the survey after the webinar, you'll see a question there, and you could type their name in, and I'll make sure to produce a certificate for those additional add-ons. Great, now it's time to transition to what we're all here for, the main technical portion of today's presentation. With us are two process engineers who have graciously took an hour out of their day here to help us with this really unique topic about biogas. Both Udi and Heidi, they've have a lot of experience in commissioning and on-site services for anaerobic, aerobic, biogas systems for industrial wastewater treatment, and it's going to be a great honor to have both of them with us here today. So Udi Sinaratne, he'll be our first panelist, followed up by Heidi Nathis, who will follow him and discuss a little bit about some maintenance items with biogas portions of your anaerobic systems. So without further ado, I'm going to hand the webinar over to our first panelist, Udi. Udi, are you here with us?
Yep, thanks TJ. And thank you everybody for attending this webinar today. And today we are going to discuss about biogas best practices, safety, cleaning options, and equipment maintenance. So as you can see on the screen, today's topics are biogas safety and biogas cleaning. So under biogas cleaning, we are going to discuss why is it important to clean, and then various cleaning methods. And then we are going to discuss about like where to use biogas, and then common biogas maintenance checklist. Next slide, please. So biogas safety, the first topic. As you all know, biogas contains flammable toxic gases and needs to be handled in a very safe manner. And all biogas handling equipment is there for your safety, and it must be maintained as per the manufacturer's recommendation to ensure it works and keeps you safe. And especially when you work in your wastewater treatment facility, you can find there are a lot of confined spaces, and don't forget that you have to follow all the confined space protocols, especially when you enter the empty tanks. And the most important thing, always wear your personal gas monitors and make sure that those monitors are activated and calibrated, because We know that biogas contains flammable and toxic gases, and especially in anaerobic environment, it means that there are no oxygen. So please always purge the biogas lines and tanks with inert gas like carbon dioxide or nitrogen, and clean the tanks before starting work in those confined spaces. In this slide, you actually can see the typical components in biogas. Methane and the carbon dioxide are the two major components. So normally, typically, like you can find like 60 to 80% methane in your biogas and 20 to 30% carbon dioxide, small amount of water vapor, like 1 to 4%, and 0 to 2% hydrogen sulfide, depending on the sulfate or the sulfur concentration in your wastewater. Biogas cleaning. So why we need to clean biogas? Basically, we need to clean the biogas because it contains compounds that can harm the downstream equipment like waste gas burners or boilers or gensets. And the big things are hydrogen sulfide and water. The biggest issue is that when those two are combined together, it can form sulfuric acid, which is very corrosive. And again, if you have H2S in your biogas, normally H2S is there in your biogas stream. So even when you burn it in your waste gas burner, it produces SOx gases like sulfur dioxide and sulfur trioxide, which is regulated by EPA. So a lot of time even to, can you go back a little bit, TJ? Sorry. A lot of time even to burn biogas in the burner, you have to scrub out like H2S first. Next slide, please. And it's very common that the water or the moisture and other particulates are present in your biogas, and these particles and water vapor actually reduce the calorific value of your gas and make it difficult to burn. So we need to remove those particulates and water vapor from biogas. And if you have silica compounds in your wastewater, so the siloxanes can be formed and can be present in your biogas, and it is actually an organosilicon compound that can harm your waste gas burners. And carbon dioxide is usually present even in purified biogas, but if you want to purify biogas to the natural gas quality, then you have to remove carbon dioxide as well. And we will discuss different biogas cleaning methods later in this presentation. And what determines how you clean biogas? First, you need to determine the initial quality of the produced biogas. For that, you need to measure the H2S concentration in your biogas and the water content and the particulates, and maybe if you have a silica-based compounds in your wastewater, you may need to measure the siloxanes in your biogas. And then the second one is how much gas you have, like how much biogas is your system producing. If you, like for an example, if you produce like 10 CFM, then you may use one method to clean your biogas, and if you're producing 100 CFM instead of 10, then you may need to use a completely different method to clean your biogas. And the third one, which is very important, so you need to determine the quality requirement of the end product. So this depends on what you are going to use the biogas in. Like if you're going to use it in a boiler or a genset, then you may need like different quality levels. So you need to determine, you need to think about that requirement as well. And there are 4 major methods to clean biogas. You can clean biogas mechanically, or you can clean biogas chemically, biologically, or physically. And let's go over each method in the following slides. Mechanical cleaning. So the best example for mechanical cleaning is actually sediment trap. So here we do not actually remove anything other than water vapor and particulates. These are very simple mechanical tools, but very, very useful. You can find these sediment traps in almost all the biogas systems, and like just to remove water vapor and particulates from the biogas stream. Chemical cleaning. So chemical cleaning, like we have 2 examples here, ferric chloride injection and oxygen injection. So let's discuss about ferric chloride injection. So in this method, we actually remove H2S in the liquid phase before it gets into the gas phase. So ferric chloride that you inject reacts with sulfides in the water and produces ferrous sulfide, which is actually a precipitate. So that way you actually prevent sulfides from getting into the gas phase as H2S. And in oxygen injection, it's actually a very good method, but it is kind of hard to control because you have to microaerate the headspace of the reactor, and it's you have to be very careful because when you do that, because if you introduce too much air, then you create an explosive environment in the headspace of the reactor. But it is a very good method to remove hydrogen sulfide from the wastewater. The caustic scrubber. So here we have a sodium hydroxide or a caustic solution to absorb hydrogen sulfide from biogas. Basically, here we have a column with packing material in it. So the caustic solution and biogas flow in opposite directions. And as they move, as a countercurrent system like H2S is absorbed into caustic solution. And this is a very widely used method to purify biogas. And one advantage is that you can remove some amount of carbon dioxide as well, because carbon dioxide is also dissolved in the caustic solution. But the drawbacks are there's no caustic recovery, so the caustic consumption is high, and you had to use a lot of caustic in this system. Iron sponge. This is actually another unit that we can use to chemically remove or chemically clean your biogas by removing hydrogen sulfide. It's a relatively cheap and widely used method to remove hydrogen sulfide if the hydrogen sulfide loading is low. So basically these systems are filled with media impregnated with iron oxide, and usually the media is some sort of wood chips. And as biogas flows through these vessels, the H2S reacts with ferric oxide and forms ferrous sulfide. This is a very the popular method, but you need to regenerate or replace the media once all the ferric oxides are spent. The amine scrubbers and the solvent scrubbers. Like the concept here is actually similar to the caustic scrubber, but in amine scrubber, like we use monoethanol amine or dimethylethanol amine to eliminate carbon dioxide and hydrogen sulfide under pressure. And in the solvent scrubbers, we use a specific solvent to increase the solubility of the particulates like siloxanes and try to absorb them into the liquid phase from the gas phase. We use those solvents to remove the particles, remove the particulates, which has very low solubility in water. Sulfothane. So this is this is actually a biological treating method, and this is actually a Veolia technology, very successful technology. So this is actually a combination of microaeration and caustic scrubbing that we discussed earlier. So similar to a caustic scrubber, we actually scrub hydrogen sulfide with a caustic solution, and but this system has a biological system as well, biological reactor. So there we actually oxidize dissolved sulfides into elemental sulfur, so we can recover and reuse caustic. So the chemical consumption is, or the caustic consumption is actually very minimal. So as I said before, this is a very successful technology from Veolia, and we have multiple installations in US and around the world. They're working really well. And similar to a bioscrubber, like this is actually, similar to bioscrubber, the biotrickling filter. But the difference is that the sulfur oxidizing bacteria are actually not living in the liquid phase, but on the fixed film media. So they can be used to remove sulfide from water or biogas. The one drawback that we have in these systems is that you need to clean the media time to time, because all the sulfur precipitates occur on the media. The mixed liquor scrubber. This would be a very good integration to your biogas system if you have a downstream aerobic system available. The concept here is somewhat similar to sulfothane that we discussed a bit earlier, but here we use an aerobic mixed liquor to absorb and oxidize sulfides. So you do not need a separate digester because you already have an aerobic system. But you may need to increase the aeration capacity a little bit to accommodate the sulfur oxidation. But this is also a very good method that you can use to remove or scrub H2S from your biogas. Physical cleaning. So in physical cleaning, most of the time, some sort of absorbent media is used. In the examples given here, the activated carbon and graphite are the absorbent media that is used, and the concept here is that we use some sort of a porous media or a material to physically trap the pollutants in the biogas. Once the pores are filled with the pollutants, the material need to be replaced or regenerated. And the third example, which is the chilling equipment, there we reduce the temperature and pressure to condensate and separate moisture and other pollutants from biogas. The water scrubber, it is another method of physically removing sulfur and carbon dioxide. So these scrubbers use the same principle as in solvent scrubbers. There's no chemical reaction, but hydrogen sulfide and carbon dioxide just transfer into the liquid phase under elevated pressure. Like in catalytic scrubber, it is same as the water scrubber, but some sort of absorbent is used in a second stage to separate particles from water. The cryogenic separation, the principle here is actually similar to distillation. We use different temperature and pressure to liquefy and separate hydrogen sulfide, carbon dioxide, and other components, other contaminants from biogas. And you can use this technology to clean biogas up to natural gas quality. And the organic scrubber, is also similar to water scrubber, but use an organic solvent here we use an organic solvent instead of water to dissolve compounds that are not easily soluble in water. The MEM gas system. So this is also a very good physical cleaning the system that you can implement. This is also a Veolia technology, and it's a very successful separation method developed by Veolia. So you can use this technology if you want to clean biogas to achieve the natural gas quality. Like if you look at the diagram at the bottom of the slide, you can see that you remove hydrogen, you remove water vapor and ammonia in a drying step, and then there's another cleaning step to get rid of hydrogen sulfide and other volatile organic compounds. And then the biogas is sent through a membrane to separate carbon dioxide and methane, and you can actually recover methane over like 97%. And the next topic would be where to use biogas, and I'm handing over the presentation to Heidi to continue on from here.
Thank you, Udi. As Udi mentioned earlier, one of the important things in determining what method you're going to use to clean your biogas is where you're going to use it. So now that we understand the cleaning methods, this is the valorization. And it's all kind of about that caloric value, and if you have CO2 or water or particulates in your biogas, it's more limited in when you can use it. So the most common are boilers or combined heat and power generators, or CHP units. These can be used to provide, a boiler on site could be used to provide hot water or steam injection to increase the temperature in your reactor. You can provide electricity and heat in general to offset some of the heat and power that you use in your process is the most common method. And these can be run on biogas or a blended natural gas and biogas. So they typically only require sort of minimal cleaning compared to the other methods, such as sludge dryers or turbines. Turbines produce electricity, which will offset in your plant. Sludge dryers, if you're looking to produce a certain quality of sludge, dryness, or for certain applications, biogas can be very helpful to use in the sludge dryer to achieve that that dryness with minimal additional inputs. And then we also have fuel cells. Biogas fuel cells are relatively emerging technology. It's a little bit less common, would definitely require a higher quality biogas or pipeline injection, where you clean to essentially natural gas quality and inject into your natural gas supply. If you have that as a local infrastructure. And then lastly, can concentrate the methane even further to CNG, or like a compressed natural gas or liquid natural gas, which can be used as a vehicle fuel support source for specialized vehicles. So we're going to talk a little bit more about some of the key safety features in biogas systems and some of the maintenance items that you should be doing regularly on those safety components. So just a quick overview of the main pieces of equipment. We have sediment traps and drip traps, which is a way of capturing the water and particulates in your system. You have back pressure regulating valves, as well as pressure and vacuum relief valves, which help you manage the back pressure in your system to prevent overpressure events. And similar check valves and flame arresters, as well as flame check valves, will prevent your flare or any flame ignition sources from getting back into your system. And we have flares to remove a biogas that's not getting used in another application. So first off, we have sediment traps. Pretty much any biogas system you'll see will have sediment traps. Biogas comes off the reactor at the particular temperature and pressure that's in the reactor. It's fairly saturated with water, not necessarily a high quantity, but you definitely have a presence of water vapor. So the sediment trap will collect the condensate or any foam that may get into the gas line and prevent it from going further into the gas line, which could cause clogs, which affects your reactor back pressure. And if you have that moisture or those clogs in the line, it affects your ability to control the pressure in the reactor, which is not good for either safety or performance. And it's important to keep sediment traps drained and clean. Similarly, we have drip traps. So the sediment trap will remove some of the condensed water vapor, but as the biogas goes through turns in the line or through valves, then it drops in pressure and it also cools, and that combination of pressure drop and temperature drop creates more condensation. So you need drip traps basically any point in the any low spots in the gas line or at any significant pressure drop location where you expect to see a lot of condensate. And that gives you an opportunity to remove that condensate from the line without having to isolate the line, because they're designed in a way that when you open the drain, it blocks off the biogas. So you don't have biogas leaks and you don't, which again, for both safety and performance. They should be drained fairly often. You should follow the manufacturer's recommendation and also adjust according to your plant situation. Usually recommend emptying them at least once a shift, and then you can kind of track how full they get. The more gas you produce or the colder the temperature at your plant, the more frequently you should drain it. The back pressure regulating valves are used to control the back pressure, which is relevant to the pressure in your reactor space. It's important that they don't get clogged with foam or condensate, especially the sensing lines, because they might not operate as designed. Some of them, most of the back pressure regulating valves, typically they're just a diaphragm. They can also be a motorized valve with a PID loop control, but it's important to note that any motorized or electrical equipment in areas with biogas need to be reviewed and most likely qualify for Class 1 Division 1 or Class 1 Division 2 installation requirements, which is pricey and more complicated. So diaphragm valves are the most common. So pressure and vacuum relief valves will be installed in the line and especially on the reactor tank. It ensures that any overpressure or vacuum situations are relieved through the valve so that the tank doesn't implode or rupture. You can see in the picture the top part of that is a pressure relief, and the part that sticks out on the side is the vacuum relief component. You need to make sure that you don't get birds' nests or other debris built up in there, because that could clog it. Also, just if you have pressure events, it's important to inspect them. You don't want to have leaks in your system if things degrade. And I guess to clarify, the overpressure may be obvious, but the vacuum relief is included because if you have a sudden drop in level or either the tank or the connected piping, you wouldn't want to accidentally create a vacuum in the system. So these valves require regular inspection and maintenance. They typically consist of a thin plastic gasket with some weights on it to hold it down, so they can degrade over time, or if they're not installed properly, you could have leaks. So it's important to follow the manufacturer's instructions for both installation and inspection. It's a good idea to have the manufacturer come out the first time you do it and show you how to do it, because they can be different, and then you will know going forward what the proper way is to inspect and repair them. Flame arresters are installed in the system. They're a pretty simple design. It's basically a box filled with aluminum plates so that any like flaming gas would pass through it and cool rapidly with contact to the aluminum. But if you get foam or scum or water vapor built up in the plates, it prevents the flame from passing through, which could cause issues elsewhere in the line. So it's important to clean and check them regularly as the manufacturer recommends. Typically, we include redundancy. You can see 2 in that picture on the previous slide, so that you can work on one while still having one in service. And they're installed, especially in lines to those relief valves and also to the flare. They're very easy to clean. You can pull out the box and basically spray it with a hose. If you happen to have scaling on it, you can probably use a pressure washer for most buildup. You might need to use some kind of acid cleaning. Again, should be included in the manufacturer's instructions what to do if you see scaling. So it's good to have a spare bank per size that's installed. For different size lines and different flows, different points of the system, you may have a different size flame arrestor. So for whatever you have, it's a good idea to have one spare one for each size so that you always have a clean one that you can install if you have a clog or an issue. And then you can pull the affected one out and clean it and then have it on hand for the future replacement. We have flame check valves in the system, which keeps or I guess not flame check valves, these are just check valves. We'll get to the flame check valves in a minute. Biogas check valves keep the biogas from flowing backwards in the line. It's important to keep these clean so that they perform their duty. It's okay if you hear them making noise. They may clink. Biogas flow isn't necessarily consistent in the system. So as the flow volume changes, the valve will open more or less. So the clinking shows that it's behaving as expected. If you have consistent flow, you may hear it less, but either way is fine. So flares are provided to ensure that any unused biogas that you have is safely burned. This prevents the biogas from building up in the system in areas where it could ignite or overpressure the system. So there's 2 main types of flares. You have an open flare as shown on the left and the closed flare as shown on the right. Closed flares are very common in areas where you have strict air regulations because the enclosed flare design allows you to control the temperature that the biogas burns at, which gives you more control over which compounds and how thoroughly they are combusted. It may also be common in situations like the plant in question here is in a downtown area, and the closed flare hides the flame from view, which could be like a public concern from some folks. All flares, both open and closed, have some way to light the flare should it go out. This could be a venturi or a spark fire or a spark igniter. Most of them have an automatic relighting system, but some of them could require a manual relight. So in the flare, you have a flame check valve, similar to a biogas check valve that stops the flame from going back into the system, into the piping. So the way these work is they have a fuse installed in the valve that if the flame hits the fuse and it gets hot, then it melts, which will automatically close the valve and prevent the flame from getting back into the gas piping. So you can check the fuse. If it's intact, the valve is open. Otherwise, if it's melted, the valve is shut. This does mean that you need a replacement fuse in order to restart and reopen the valve. Sometimes with Varic flares or other systems, they might wrap them onto the unit, but you need to have spare fuses on hand and you need to know where the spares are, whether they're attached to your flare unit or stored in a safe location. But otherwise, you won't be able to restart the flare unless you can replace the fuse. Then going back to the open flares, they're open, you can visually see the flame burning. Some use a venturi to mix air in the pilot gas, which is ignited by a spark plug in order to light them. There is a thermocouple in the pilot, and you can use that thermocouple temperature to tell you whether or not your flare is lit. it is assumed if your pilot is lit, then your flare is lit. So in terms of a remote indication from a SCADA, for example, it's important to keep the venturi clean so that your pilot is able to light the flare, and to make sure your gas regulating valves work. And you need to check that relight function annually so that your flare will relight when it's needed. With closed flares, you can't visually see the flame, as I mentioned, and sometimes or often the flame temperature is controlled. For the control of the temperature, it has a louver system to control the airflow, which helps control the temperature. So you need to make sure that those louvers move freely so that you have the appropriate airflow, and you need to make sure that the pilot lines are open and clear and the sparker is clean. The general pilot mechanism is similar to that for open flares. So that's kind of the main topic for today. So I think we have a good amount of time for questions. I'll hand it back to TJ.
Great, thanks Udi. Thanks Heidi for sharing that experience and that knowledge. And just to remind everyone, on the right side of your screen, you should see that question panel. And if you have a question, go ahead and enter it in there. We received a few throughout the presentation, which we'll get to now. I guess I'll start us off. We had someone who attended that they're asking that they say that they get water in their biogas lines, which happen to be underground. In this case, what kind of maintenance advice or operational advice could you give this person?
Go ahead, Udi.
Yeah.
Okay. Hopefully that you can collect condensation from any points that are above ground. There's probably a way to clear out the lines periodically, but it would require more equipment and possibly isolating the system. But you'd want to make sure that you have traps installed at the areas that are above ground and accessible, so that you can remove as much as possible from the system from the accessible areas and prevent having to do more complicated maintenance, would be my suggestion.
Great. A similar question that we received, it says that this particular system has not collected any water from their sediment traps in the past 3 months. Can you talk if you've seen that before at other sites, or is that a common occurrence, or is it an uncommon occurrence?
Yeah, sometimes I have seen that in certain plants, it actually depends on the weather as well. So like the moisture content is actually really low, and so yeah, the sediment trap actually does not collect like a considerable amount of water. That can happen, but the most important thing is that we need to make sure that the sediment trap has the right amount of water level there. So whenever some moisture comes in, so then like you maintain a certain level in the sediment trap. So when you get excess water, so it automatically leaves the system. So otherwise, like you might accumulate water in the sediment trap, but you really do not notice that. So it's always important to maintain the right water level in the sediment trap. But on the other hand, so I have seen certain instances that the biogas contains like very little amount of water vapor, so you really do not notice that.
Great, thanks, Udi. A question came in. How common is it to retrofit biogas cleaning equipment into an existing anaerobic system? Have you seen many retrofits or installed systems or equipment on existing anaerobic plants?
Yeah, we have done it like multiple times. Like normally, like if we design the plant from the scratch, we actually analyze the hydrogen sulfide concentration and other contaminant concentrations that can present in the biogas, like theoretically calculate that and then decide if we need any biogas cleaning equipment on the biogas line. But yeah, you actually can retrofit and add a cleaning system, like especially when it comes to sulfothane. Like we have installed sulfothane systems in old plants. Like they already have the biogas system, like biogas lines without any cleaning steps. So you just need to cut the line in between and then install this system. It's actually, we have done that. It's fairly easy to do, easy to do that.
We have definitely seen it be common either if the wastewater content changes or is misestimated in terms of higher than expected sulfur, or we've also seen plants where they want to start using their biogas in a CHP or something that requires a cleaner level than they had before. So it's definitely common to retrofit.
In regards to the sulfothane system, the question that came in there is the byproduct produced from that system is sulfur. What do you do with that sulfur? Is it a hazardous material or can it be safely landfilled?
Yeah, that's a good question. So the sulfur, normally you actually can send it for landfilling. So it depends on the state and the regulations. So it depends on the on the state environmental regulations. So normally, like I have seen, so in certain sulfothane systems, like the sulfur can be sent out for landfilling. So sulfur itself, as elemental sulfur, is not hazardous because it's not reactive.
And is there any way to valorize that residual sulfur that comes off that system, fertilizers or anything like that? Have you heard of any cases of that?
It is possible. I don't think it's as common in the US, but it is an ingredient in some like sulfate fertilizers. I think it would depend on what your local market is like and if you happen to have someone who could use it. So not necessarily common, but I'm fairly sure it's possible.
Great. I got a preventative maintenance question here. It says that at this particular site, our equipment goes through preventive maintenance every other year. Is this okay, or should it be done more frequent? I guess it could depend on the anaerobic system, the biogas equipment. So maybe you could comment a little bit about what is recommended from your perspective. Is that something you could handle, Heidi?
I mean, it really depends. If you're not seeing any issues in your system and you're following your manufacturer's recommendation for the individual pieces of equipment, there's no set frequency that you have to do things. But if you are running into issues, it's definitely something that the more often you do it, the better your system should run. And it's, again, as we've said many times, it's important, especially for the safety features, that you review the recommendations and follow that. But for the most part, you know your system, and it varies hugely from pieces of equipment to piece of equipment, and how corrosive your local environment is and your wastewater contents and a lot of other factors.
Okay, here's a real specific maintenance question here. It says, what type of lubricant do you recommend for the valves that switch the two digesters top PRV vacuum breakers? And this particular aspirator says that they're in a colder climate. So do you know what would be the recommended product for that?
That's not something I can answer offhand. Can send a follow-up and we can look into it.
All right. Well, I don't see any more questions coming in, so we're just about at our 45-minute blocked off time for this webinar. If you have any additional questions, you could reach out to me first, and I'll get it to the right technical contact. My email is right there on the screen. I just want to first thank both of our panelists who spent time in preparing this content and reviewing this content, and also adding in all of their field experience for today's webinar. It was really interesting and really beneficial. But also I want to thank all of our customers who joined us here today. You took an hour out of your day to learn a little bit more about how to better operate your system, or some enhancements that you could do to make sure your systems are operating at peak performance. We're really glad that you spent that hour with us. So be on the lookout for an invite in a couple of months. We're going to do this about quarterly, so look out for that. I just want to remind everyone that the PDF participation certificates will come out in about a day or so. And also, don't forget to take that survey immediately following the webinar. It helps us improve these, and also there's a place in there to enter some information of future topics that you may be interested for our panelists to cover. So again, I'd like to thank everyone, and I hope everyone has a great day. Take care.
Thank you.